Sometimes you get told that speed is equal to distance divided by time. And whilst that is close, it's not the exact truth. It's true when the speed is constant. It's true if you're finding the average speed, but it's not quite true if you're finding a speed that's actually changing, which is the case here. Because if I was to have a constant speed, then I would get a straight line. I don't have that. I've got this. I can see that actually the speed is increasing because I'm going further later on than I am at the start. I'm only going, a tiny amount in the first second, whereas I'm going quite a few meters in the last second on this graph. What we actually have to do is we have to find the instantaneous speed at 5 seconds. So that is here, but I need to look at therefore the gradient of this curve. That's what gives me the speed, because when you have a constant speed, it still works, because if you have a straight line like so, then yeah, distance over time will give you the gradient. But if I do distance over time here, here, if I do 3 divided by 5, that would give me the average speed over the first 5 seconds, but not the actual speed at 5 seconds. So here's what I do after I've gone into some detail on that. What I need to do is draw a tangent. I can't remember if I already said that, but get a tangent, and so I need my ruler for this. And at 5 seconds, I want it to just touch the curve, which it doesn't quite do. It's not bad. I think I could do a bit better. Just keep doing it until it just touches, just glances off the curve. That's pretty good. I'm happy with that. And then draw a line along, and I would make it as big as possible, to be honest. Like, just don't make it tiny. And it helps, I think, if it goes down to 0, because that'll make one of your readings easier. And let's go all the way up to 8 seconds as well. So there we go. Just glancing off. I might even want to move it up very slightly. Okay. So now I'm actually finding the gradient of this straight line. That will represent the speed at 5 seconds. So I'm going to turn it into a triangle, and I can see if I read off the graph that the change, the rise is actually 7 meters. And then the run, the amount of time, is going to be 8 minus 2.8, it looks like. So it's going to be 7 divided by 5.2. Now, the reason this is an estimate is that you can see, I don't know that this is true for sure. I've just drawn a tangent. There could be a range of values accepted. As long as I'm roughly thereabouts, that's okay. And I see that I get 1.346. And because it's an estimate, I mean, you might get away with rounding it to 3 significant figures, but I actually think we should just give it to 2. But because I've given it the exact answer, at least a 4, then I'll be okay either way. But there we go, that's my answer.